Hello dear friends, welcome to this video. In this video, I'll be talking about these two guys. The first is S and the second one is S. Do you know them? Most probably the answer is no. But every mathematician must know at least their name, not the face. Might be. So if I just tell you the person which I show you first is nothing but the Bolzano, the great mathematician Bolzano. Can you guess who should be the next? And I hope you are guessing it correctly. It is nothing but Weierstrass. So this is nothing but the pair who gave us a famous theorem called as a Bolzano-Weierstrass theorem. Okay, wait. What I said is it is just a pair who gave. Most probably I am somewhere wrong. There is a great history behind this theorem. This Bolzano-Weierstrass theorem, if you see, they two never worked together to get this theorem. What actually happened is the Bolzano proved this theorem as a lemma of one of the most simple and interesting fundamental theorem in real analysis, that is nothing but intermediate value theorem. Bolzano proved this theorem, what we today call as a Bolzano-Weierstrass theorem, as a lemma of intermediate value theorem. After he proved it, 50 years passed and suddenly this result found out to be more applicable in real analysis. And this result was again proved by Weierstrass, and this result became very famous and now become a essential part of real analysis. So that's why the name came. Bolzano was the first to prove it. Weierstrass proved it again after 50 years and make it so famous that now this is known as the Bolzano-Weierstrass theorem. And if we see simply, it is just an application of intermediate value theorem. Let's see the statement over here now. What is Bolzano-Weierstrass theorem? One of the most fundamental thing about real analysis is working on the concept of sequence. This statement tells me that if I have an infinite sequence which is bounded, then it must have at least one convergent subsequence. Every bounded sequence, not only in real number, this result is true even in any higher dimension of real number, that is Rn. If you have a sequence in Rn, an infinite sequence which is bounded, then it must have a convergent subsequence. While reading this, one should note that I am not telling that that sequence is convergent. I am telling that it must have a convergent subsequence. For an example, I could give you this minus 1 raised to it. This is my sequence in R, which is infinite. Yes, it has infinitely many terms as I take n tends to natural numbers, right? N are any natural numbers. Which is bounded. Yes, it is bounded. Since any term of the sequence is bounded, I could say it is bounded by 2. More precisely, it could be by 1 as well, in less than equal to 1. But yes, it is bounded. So by Bolzano-Weierstrass theorem, it tells me it must have at least one convergent subsequence. How do I see this sequence? I see it like minus 1, 1, minus 1, 1, minus 1, 1 and so on. If I just consider only odd terms of this, that is nothing but minus 1, minus 1, minus 1, dot, all are minus 1. This is a sequence which is converging to minus 1 because it is a constant sequence. And if I see the given sequence is divergent because it is not converging anywhere. The given sequence is not divergent, but it has a convergent subsequence which is obtained by considering all odd terms. Similarly, if you consider all even terms, it is 1, 1, 1, so on, and it converges towards 1. It is also convergent. I found two subsequences of it which are convergent. I could find out infinitely many subsequences of it which are convergent. But what does this statement tell? It tells that it has at least one convergent subsequence. Right? I hope you understand this statement now, and whenever the situation comes, you should be able to apply it. This situation is true for any Rn at present. You can even generalize it for more dimension of metric spaces and topology, but in real analysis in general, it is true for Rn. If you have a bounded sequence, infinite bounded sequence, then it must have at least one convergent subsequence. Right? So that's all about the statement. In next video, we'll be solving some more questions. Okay? Thank you. And apart from this, if you like it, please share and subscribe to the channel. Bye bye.